Hello, everybody. I'm Tycho, first-year master's student, and I've been the one that's been working with Hoover. Thank you guys for taking over that responsibility on Monday. I'll be down in LA for the summer, so that's why I won't be there. Great. So I figured it'd be great to give an update just on what I've been doing this past year, working with Professor D'Amico in his capacity as a science fellow at the Hoover Institution. So this project is focused on space safety and sustainability. Let's squeeze something. Okay. Awesome. So I'm just going to go through why is this important, why are we doing it, how it pertains to the work, the more technical side of the work in the lab, the goals of this project, how we went about achieving these goals, and where we are now, and some next steps for the future. Okay, so the motivation behind this, as you guys have probably heard a lot about the space sustainability paradox, which is the phenomenon whereby the increased use of space for the benefit of Earth leads to adverse impacts on both the space and the Earth environment. What does this mean? Space-like technology today is the invisible backbone of global economy, modern society, national security. You all are very familiar with all this. GPS, is essential to everyday life, from navigation and cellular networks. Earth observation is essential for weather forecasting, early missile warning systems. So we classify all of this as safety, sustainability, security from space. We really say sustainability, but safety and security are looped under that umbrella. On the flip side of the coin, however, unregulated spaceflight poses an existential risk to our access to space. Again, you all are very familiar with this, but the number of objects in orbits have been doubling, tripling, depends on however much you want to look at it. The bottom line is that space has become congested and contested. So we're referring to this as the safety, sustainability, security of space. So the paradox really is weighing the benefits that we get from sustainability from space versus the risks of the sustainability of space deteriorating. All right, so the goal of this project is to combine the technical expertise that we have here in the lab, along with the policy expertise at the Hoover Institution. As Professor D'Amico just mentioned, there's this new initiative at the Hoover Institution called the Technology Policy Accelerator that aims to bring technical expertise in order to help recommend and shape policy, in Congress. So we want to combine these two to really make a meaningful impact on space safety and sustainability through both technological development and policy recommendations. We've seen a lot of initiatives that come from one or the other side of this, but really you need an approach that understands both the technology side of what operating space is like today, along with how do you affect actual policy that reflects the reality of the technology. So that's the goal of this entire project. How we go about doing this? This whole project's under the initiative named the Leadership for Responsible Space Policy, which is also again under this Technology Policy Accelerator. And the end goal is a two-part report that's going to be aimed at Congress and the new National Space Council. We divided this up into 3 phases, each phase sort of mapped to a quarter throughout the year. The first one was investigating the state of the art in space sustainability technology and policy. And this was in the fall, and that's now complete. The deliverable here was a working paper that is in the process of being edited and published as we speak. The second phase was going out and interviewing the relevant stakeholders to understand the major gaps and challenges and also identify some of the potential solutions. This was happening over the winter and spring quarters. And finally, the third phase, which is still ongoing right now, is to develop and publish actual technology and policy proposals. And we're going to do this by hosting a workshop in October in DC, in the Hoover office in DC. And then the end goal is sort of the part 2 of this full report, where we publish these proposals and disseminate to congressional stakeholders. So that'll be happening, in the spring and the upcoming fall. So to dive a little bit deeper into the details of here, in phase 1, the deliverable has been a 30-page report that, again, is going to be published pretty soon. We've covered a variety of topics. Don't have time to go through all of these, but we're talking about why is the space sustainability paradox important. Really, we want to send the message to people that are outside of the space community. Like, everybody in this room understands why this is such a huge issue. But why do people that don't talk about space all day why should they care about this? So we want to frame that context. Then we looked at, okay, how do we operate in space today? We came up with this figure. Again, can't go into too many details right now, but some of the big takeaways is this architecture of ground in the loop, right? Very heavy ground in the loop. It has been for decades. And specifically, we want to highlight everything sort of revolves around the U.S. Space Force's Space Object Catalog, which is somewhat outdated and not really able to scale to the needs of tomorrow. For instance, this Space Object Catalog doesn't provide any uncertainty data with the observations that it publishes, but still, this is the best that we have today in understanding what's going on in orbit. Another key thing we want to highlight, of course, is the space-based sensors, which are relevant to the NASA Starlink mission that we have going on in the lab right now. But this is the sort of way that data ephemeris gets passed around between operators and these space situational awareness providers today. Yeah. So then we were looking at the policy landscapes for both the international and the domestic side. And finally, looking at analogs between aviation, maritime, and ground. How does like air traffic control work, and how that can translate potentially into the space domain? And then, looking up at some promising technologies and some key issues. So going into the international landscape, these are some of the major stakeholders in the international space policy today. The major takeaway from this is that the major landmark treaty is the UN Outer Space Treaty from 1967, and it had a few follow-ups. But since then, there really hasn't been anything on the international side of things, and this is starting to change. More recently, in 2023, the EU has this zero debris charter, and the UN has this Pact for the Future, but both these are totally voluntary. Still, international space policy works by the structure is set up such that the UN Outer Space Treaty makes every nation responsible for regulating its own space activities. So really, when you set precedent and you have these committee meetings in the UN Office of Outer Space Affairs, it sort of trickles down to domestic policy. So it still is a very effective tool if we can get some more major progress on this landscape. On the domestic side of things, again, here are some of the major stakeholders and some recent acts that are pertaining to space sustainability that none of which have been passed quite yet. But the Orbits Act is looking to create an active debris removal demonstration mission through NASA. And then more recently, the Safe Orbit Act was actually introduced just a few months ago, which supports this traffic coordination system for space, which is the next generation space traffic coordination system that is now being moved from the U.S. Space Force and Department of Defense to the Department of Commerce. There's a lot of nuance and some pushback on this new system from both within the government and from commercial players. But really, it's trying to modernize what Space Track and the Space Object Catalog is today. So we're seeing some interest and movement on these fields within the U.S. as well. But of course, more is needed. So through that research, we identified, the major stakeholders in both domestic and international, government, commercial, academia, and then we went out and talked to them. So here's some of the highlights of people that we talked to: the first chief of the U.S. Space Force, director of UN Office of Outer Space Affairs, the former chief of the National Space Council, and the sustainability lead at SpaceX. Of course, there's lots more people that we talked to that's the traffic coordination system, and people within academia that work on orbital environment modeling and solar flex data and stuff like that. So what we really wanted to do was understand what are these major themes that keep coming up from all these different stakeholders' perspectives on what are the big issues and what potentially we could do to solve them. Of course, we heard a lot of different opinions here, but we did see some major themes emerge. We can't go through all of them right now, but I wanted to highlight them through two quotes that we came from these interviews. And on the technology side, one of the operators that we interviewed talked about how some other operators today are basically driving along a busy highway at night with no headlights in space. So the analogy being you have a lack of this ephemeris data sharing, you're moving at 10 times the speed of a bullet, obviously, and Nobody really knows exactly where you are. So it's some very reckless behavior. The mega constellations such as SpaceX and Kuiper are actually the leaders in this, in that they share a lot of their ephemeris and they do a lot of collision avoidance screening. Um, but this was one of the key issues that we kept on hearing come up again and again. Also on the technology side, we've got millions of untracked objects. That's just based on they're too small. Current modalities can't see them, and large uncertainties around these objects from the way that we observe them today. And then on the policy side, this quote really helped us frame why this is so important. And this is from the National Space Council, former National Space Council person we talked to. With what we're really talking about with space sustainability is the national security and economic security of the entire U.S. And this is the message that we really want to go to Congress with, right? Like, why should we care about this? Space is in critical infrastructure, but we feel like this isn't being talked about enough. And part of that problem is that today there's a lack of unified national vision for the U.S. The National Space Council, which is reintroduced under the first Trump administration, was disbanded. So every agency sort of has their own agenda, but they're not all coming together with one unified vision. That new traffic coordination system, like I said, faces some pushback. And then there's also limited coordination between international players, especially with China and the West, which is becoming increasingly relevant as they're sending up their own mega constellations. But a key point here I wanted to highlight was just how intertwined the policy and the technologies are, right? So we have the policy implications of like, how do you share data between countries that might not like each other very much, along with the technicals of like, okay, how can we observe objects better from all these different countries? So really you need to come with a technology and policy approach to try and address these issues. Of course, we've seen a lot of this in the news as well. Last year, there's just this near collision between a Russian spacecraft and NASA, and then China is sending up these mega constellations that are operating in the same orbital shells as Starlink, which, as you can imagine, could be problematic. We've heard there's been some success with SpaceX kind of back-channeling their ways with commercial companies in China, but that really isn't, again, going to be sustainable or scalable for the future. So that brings me to the third phase, which is still ongoing. But from these interviews and our research, we've come up with a few preliminary proposals. The first one being, of course, invest in emerging technologies. So this could be active debris removal or space-based sensing, which again, this lab is much very familiar with and on the cutting edge. Starling, we are looking into how it can help improve our understanding of what's going on in the orbital environment. Even improving just space track data would be immense for reducing the number of collision avoidance maneuvers that anyone needs to do. SpaceX did about 100,000 collision avoidance maneuvers just last year alone. So this is becoming a really big problem due to the uncertainties that we have in orbit. Data fusion with commercial sources is another big one. There's a lot of commercial SSA providers out there, but they're not well fused with the government sources today to provide that more complete picture. Another category is updating the licensing processes that you have to go, every space company has to go through the FAA and FCC to get their license to operate in space. And we've heard about these industry developed best practices documents. So Kuiper, Starlink, OneWeb have come together and actually laid out like, this is how we think the best way to operate in space today is. And these are the people that own the most satellites and operate the most satellites in space right now. So we're really thinking, okay, we can take these, why don't we make these part of the actual licensing processes to get and incentivize all these operators to adhere to the best practices guidelines. And this could also be done with something like a space sustainability rating and incentive. We don't want to hamper commercial development of space or anything like that, but we want to incentivize behavior that's going in the most sustainable direction. So this could go along with insurance, right? If you have a higher sustainability rating, maybe your insurance is lower because you're less likely to be hit by debris or be able to not maneuver. And the third category is supporting the governing and counseling bodies that already exist today, funding that new traffic coordination system to determine what commercial operators need today. We hear a lot of complaints about why space track sucks. So why don't we take that and actually try and make a new version that is much better? And we still hear complaints about how they are failing to do so right now. Supporting the UN Office of Outer Space Affairs, as I mentioned, multilateral fora are a great way to actually get countries to come and agree together because although it's very slow, they published guidelines on long-term sustainability. It took them 15 years to get that through the UN Office of Outer Space Affairs. That was because every country had to agree on every single word that was going in there, which again takes a long time, but make sure that everybody's on the same page. So it's a really useful fora to convene and pass some agreements. And finally, reviving the National Space Council, which may or may not be happening right now, but who knows with this administration. Great. So for next steps, we want to publish that state-of-the-art working paper, which will be part one of the full report that's going on right now, should be published in the coming weeks and months. And then we're hosting this summit or this workshop in October in the Hoover, DC office, where we're going to convene a lot of the experts that we talked to and a few other selected stakeholders to really have like an actual working workshop where we're going to develop these proposals and then eventually publish them in our final report, which will happen again in the fall of next year, so that we can hopefully get some movement on this in Congress and the National Space Council. And that's about it. Thanks, guys, so much. I'd love to answer any questions. And if you want to take a look at the executive summary of the working paper part one, there's a little QR code there. Thanks.